In this video, we will continue to talk about how to simplify radicals. The only difference today is that there is already going to be a number in front of the radical. So we are going to add one additional step compared to our steps from yesterday. So remember that from the day 2 notes, step 1 is to always check to see if the radicand is a perfect square number. Oops. Because if it is a perfect square number, then you just take the square root and your answer will be a whole number. If it isn't, then you're going to move on to step 2, and starting with the highest perfect square number that is smaller than the radicand, you're going to keep dividing until you find that even factor, that even perfect square number that divides evenly into it. Once you find that number, then step 3, you're going to take the square root of that largest perfect square number, and then in step 4, you're going to leave the other factor under the radical or under the square root. Now, step 5, this is the new step, the additional step that we're going to add on. If there is already a number in front of the square root, then you're going to multiply that number by the simplified radical. So multiply the simplified radical by that number. So if there's already a number out in front, we're just going to multiply it by whatever we get when we take the square root of that perfect square number. So let's look at some examples together. So for the square root of 50, we're just going to ignore the 7 for right now and just bring it straight down. I know that 50 is not a perfect square number, so I'm going to see what is the largest perfect square number I can divide 50 by. So you may want to use that chart from yesterday's notes to kind of work your way backwards. And 25 ends up being the largest perfect square number. It's 25 times 2. So I know that the square root of 25 is just going to become 5, and then I'm going to leave the 2 under the square root. When I bring down the 7, I'm going to multiply the 7 by that 5 that just came out of the square root. So 7 times 5 gives me 35 square root 2, and that's the final simplified answer. Let's do the same thing in number 2. So again, I'm going to simplify the square root of 98 and just bring the 10 down. The largest perfect square number I can divide 98 by is 49 times 2. The square root of 49 becomes 7, and then leave the square root 2. And then when I bring down the 10, I'm going to multiply 10 times 7 to get 70 square root 2 as the final simplified answer. In example 3, I'm going to break down the square root of 28, and the largest perfect square number that goes into 28 is 4 times 7. The square root of 4 becomes 2, and then leave the square root of 7, and then multiply that 2 by the 5 in front. So you end up with 10 square root 7 as your final answer. Number 4, the square root of 196. This is actually a perfect square number. This is just 14. So then when I bring the 6 down, I'm just going to multiply 6 times 14 to get my final answer of 84. Okay, let's move on and do a few more examples on the back page. Starting with example 5, I'm going to break down the square root of 45. And the largest perfect square number that goes into 45 is 9 times 5. The square root of 9 becomes 3. Bring down that square root 5 and then multiply it by the 2 that was already in front. So I end up getting 6 square root 5 as my final answer. In example 6, the square root of 24, the largest perfect square number that I can divide it by is 4 times 6. The square root of 4 becomes 2. Bring down the square root of 6 and then multiply the 2 by that negative 4 in front. So I end up with negative 8 square root 6 as my final answer. In example 7, breaking down the square root of 27, you can do 9 times 3. The square root of 9 becomes 3. Bring down the square root of 3 and then multiply that 3 by the 5 in front. So you end up with 15 square root 3 as your final answer. In example 8, I'm going to break down the square root of 80, and the largest perfect square number I can divide 80 by is 16 times 5. The square root of 16 just becomes 4, and then bring down the square root of 5, and then put that negative sign in front. So I get negative 4 square root 5. Number 9, breaking down the square root of 8, I can divide that by 4 times 2. The square root of 4 becomes 2. So I get 2 square root 2, and then I'm going to multiply that 2 by the 8 in front to get 16 square root 2 as my final answer. For number 10, the square root of 147, the largest perfect square number I can divide 147 by is 49 times 3. The square root of 49 just becomes 7 square root 3, and then multiply that 5 by the 7 in front. So I get 35 square root 3 as my final answer. In number 11, the square root of 64, this again is the perfect square number. So this just becomes 8. And then bring down the 2 and multiply 2 times 8 to get 16 as your final answer. Finally, last example, example 12, breaking down the square root of 136, 4 goes into it. 4 times 34. The square root of 4 becomes 2, square root 34, and then multiply that by 2 that's in front to get 4 square root 34. So really the only difference in today's notes is that if there is a number in front, you just need to multiply it by whatever number comes out of the square root. Feel free to reach out to your teacher if you have any additional questions.